Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 6 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1161. Maximum level sum of a binary tree, right? So in this problem, you have given the root of a binary tree. The level of its root is 1. The level of its children is 2, and so on. We have to return the smallest level x such that the sum of all the values of nodes at level x is maximal, right? So see this example number 1. So this is nothing but your level. Root is at level 1, right? So here this is nothing but level 1, right? This is level 2. This is level 3, right? Clear this thing, right? Now whenever we have to traverse level wise, right? Like here first level, then second level, then third level, right? Always think about BFS first, right? I will show you two approaches. First is BFS, second is DFS, right? But my favorite is this BFS one. It's very easy for level order traversal, right? So what we are going to do here, right? So this is your root, right? This is your root, and we have to calculate the sum as well, right? So here what is the meaning of this thing first? Smallest level x such that the sum of all the values of the nodes at level x is maximal, right? Here it is saying that we need to find out the maximum value in any level, right? So here let's say the sum is x, sum is y, and sum is z, right? So among all these three levels, maximum sum we have to return at which level the maximum sum is there, right? So here in this the sum of 7 plus minus 8 is just minus 1. In level 2 sum is 7. In level 1 sum is 1. So at this particular level, right, sum is max. So we are just going to return this level 2 as the output. So we return the level with the maximum sum, which is level 2, right? Now it is clear that we need to find out the maximum sum in any level, right? Now what is the meaning of this smallest level x? So let's suppose here we have 0 instead of minus 8. So now in this level also sum is 7, in this level also sum is 7, and in this level sum is 1. Now in this case I have to return the smallest level 2 as output, right? Both are having the same sum, max sum, right? So in this case I have to return the smallest level. That is the meaning of this. Clear this part? All right. So now you are clear with the problem statement and the example, right? So in BFS, let's see BFS. So in BFS, what we do, right? So in BFS, we used to take one queue, right? And in queue, we pass the nodes, right? So first, in my queue, I'm going to pass this root node, right? And it is given that the number of nodes in the tree is in the range 1 to 10 to the power 4. So root node is always there, right? So in the starting itself, in my queue, I'm going to pass this root node, right? Clear this thing. Now what is the size of my queue? So size of my queue is just 1, right? And sum as of now it is 0, right? Clear? And now what I will do, I am going to run one for loop, right, from 0 to 1, right, until here. So done. And then I'm going to poll this element. I'm going to poll this element, and I'm going to add this element children's, right? So left, right, this cur dot left, it is not equal to null, just add this node. Cur dot right is not null, add this, right? 7 and 0 I'm going to add. Done this thing. And here in this loop, previous loop, I will find out the sum, right? So sum, I just poll one element, right? So sum is just 1, right? Sum is just 1. So this is the current sum as of now, right? And I will say that uh, after completing this level, right, my answer I will just update it to 1. My level I will update it to 1, because in level 1 only I have seen the maximum as for, right? So maximum I will say is equal to 1 as of now, right? Clear this thing, right? Right, now this is done. Now I've added the children of this 7 and 0, right? Now after this, again, size of this is 2 and sum again start from 0, right? Now I'm going to poll this 7 and I'm going to add the children of 7, 7 and minus 8. Then I'm going to poll this 0, right? And uh, I'm going to add the children. There is no children for this 0, right? So overall sum at this particular level, I poll this 7 and then 0. Sum 7 plus 0 is 7. So sum is 7, right? So at this particular level 2, right? At this particular level 2, right? So level also I'm going to increment side by side, right? Because I need to update the level as well, right? Side by side. So I will do level plus plus. So here in this, I see the sum is 7. 7 is greater than this max sum, right? So I will update it to 7 and this level is 2, right? And my answer is going to be 2. Clear this thing? Now for this 7, I'm going to, this is level 3 now. Level 3 start. And in level 3 also I see size is 2. So again, I need to poll this. So poll this 7, there are no children for this, right? And then I'm going to poll minus 8. Poll this, there is no children. So 7 plus minus 8, sum is minus 1. So minus 1, no, max sum is 7, right? This is greater, so I don't need to update anything. So in the end, my queue becomes empty and I will just update the answer, whatever the answer I have, right? Okay. And this level I will just increment. Actually this is third, so here I'm just in this level I will just pass the level. So initially it is 1, then after that it is 2, after that it is 3, right? And answer, in answer I will store the that particular level in which I will get the maximum. Okay, so this is how I'm going to solve this problem. Very easy. When I'm going to write the code, so it will be very easy for you, right? So here initially the answer is equal to 0, right? And you can take a level initially equal to 0 and you can take max sum initially equal to 0, right? Clear this thing, right? Okay. And here what you can do, okay, one more thing. Here if you see the constants, so node dot val from minus 10 to 5 to 10 to 5. Okay, so it is good that if I take maximum 0, because maybe I will get the negative values everywhere, right? So for simplicity, let's place the root dot val, whatever root dot val here. Okay, right. Now here in the queue, I'm just going to update tree node and q is equal to new linked list. Done, right? And in the queue I'm going to add what, the root starting, right? This is done. Then I have to simply run one while loop while my queue is not empty, right? Is not empty. Okay, so now in this what I need to do, first find out the size of this. Int size is equal to q dot size, right? And here sum is equal to 0, and then here you have to just run one loop. Int I is equal to 0, I is less than size, and here I plus plus, right? And here just get the current node. Okay, cur is equal to q dot poll, so you get the current node. Now in the sum you have to add this value, right? Cur dot val, right? So for this particular level we are polling, adding the children and calculating some side by side, right? And here I will just simply write, if cur dot left is not equal to null, then we have to add the left children, right? So q dot add and here cur dot left, right? This is done. Same way for the right children we have to do, if cur dot right is not equal to null, then in the queue you have to add cur dot right. Clear? This is done, right? So here your for loop ends, right? So we calculate the sum at this level. Now here I will just check na, if the new sum that I get, if it is greater than the max sum, right? Max sum. In that case, what you need to do, right? So this is what I'm doing, right? Here, if you notice one thing, sum is greater than max sum, right? This is level 1, right? So if I'm taking the max sum of the root dot val, so let's do one thing now. In the level, just give it 1, right, in the starting, and in the answer, just give it 1 initially, right? Right, this is a very base case. Okay, so if I'm taking the max sum of root dot val initially, so that is for level 1, right, and answer is equal to 1 initially, right? So here, if later on in any stage, if I get sum greater than max sum, right? So as of now uh, initially I add root, right? So size is 1, right? So this is I will get the same thing. This is for root only, right? For the very first case, I will get the root result only here in the sum. Then after that, I will get the level 2 sum, level 3 sum, like that. Okay, so as of now, this is just for level 1 I'm doing, right? So here I will just update max sum is equal to sum, right, and answer is equal to level, right? And here I have to increment the level every time, level plus plus, right? That's it. And here you have to simply return answer. Only 27 lines of code. That's it. Okay, now let's run the code. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are clear with this BFS approach, right? Now I will move to the DFS. So DFS is also very easy, actually, not complex, easy only, right? First, we are going to start from our root. Okay, we are going to start from root. Then I'm going to cover the children of this, right? This here I will reach. Then after that, here I will check, right? So in this manner I'm traversing. Then for this I'm checking this, then I'm going to check this. Okay, so in this way I'm going to traverse, right? So let's see how I'm going to solve this problem using DFS, right? So initially I'm going to create one array list. Initially array list is empty, right? There is nothing. I just created it, no size, 0 size. Okay, so now I'm going to start from here. Okay, so I'm going to call this DFS root, and here I'm just going to pass 0. So this is the node I'm passing, and this is the depth I'm passing as of now, right? Okay, now here this node is not equal to null, right? Clear? And depth value is 0, and this array list size value is also 0, right? Clear this part? Okay, both are 0, right? So this is nothing but your array list level sum, right? So size of this is 0 and depth is also 0. So that simply means for this particular depth, I am getting the very first element, right? So what I will do, in the level sum, I will add this 1. Okay, I have added this. In the array list, I have added this element. Okay, done. Now after that, I am going to check the left of this. So I am moving here, right? So if I am moving here, so what I will do, I am going to pass this particular node, that is nothing but the root dot this node dot left, right? This node dot left I will moving, right? So I can say previous nodes left, and this is nothing but depth is going to be increased. Initially it is 0, so now new time the depth is going to be incremented by 1, right? So this is what I'm going to do, and I will reach here, right? Now once I reach here, if you notice at this particular level, right, depth is I'm passing 1, and the size is also 1. Okay, array list size is 1, and here in this case depth is also equal to 1, right? So that simply means I am seeing the very first element in this level. Okay, very first element, because in DFS we move it like this only. So I'm going to add the 7 here. Okay, I'm going to add 7 here. Then for this I'm going to move to the left. So in this my depth is going to become 2, and depth is 2, right? And my level sum array list size is also 2. So I'm going to add this element 7 here. Clear? Clear this part? Now After this, there is no left, there is no right. Okay, I'm going to return. So for this I cover the left. Now I move to the right. Okay, so here at this position I reach, but this is having depth 2. This is having depth 2, right? This minus 8 is at depth 2, right? But my level sum array list size is 3, not matching, right? If it is not matching, that simply means this is the not the first element. This minus 8 is not the first element in this particular level, right? So what I will do in this case, add this particular depth 2, I will get the previous element 7, and in this I'm going to add this minus 8. So I will get minus 1 here. I will update minus 1, right? Then there is no left, there is no right. I am going to return from here. Then I have already solved this. Again, I will return. Then I will move here. Okay, so here this is nothing but depth 1. It is depth 1. So right now this size is 3, but this depth is 1, not matching. So that simply means at this level 1, depth 1, I have already seen one previous element in this particular level. So in this I will add the 0 and I will get 7, right? There's no left, there's no right. Okay, then I'm going to return back to here, and that's it. So I have solved all the sides, right? Parent, left, and then right. Okay, I've solved everything, right? So now in the end, you have to just iterate over all these 1 2 3. So among them max is 7, so you have to return 7. That's it. So this is how your DFS works. Okay, let's write the code for DFS now. Right. Okay, so here what you need to do, first create one array list. Okay, so in the class solution, here you have to just create one array list of integer is equal to level sum, name it level sum, new array, and here you can say list. Okay, this is done. Now here I am saying just call this method DFS of root, and here just pass 0. Done. So now this DFS, right, it is going to help you calculate, fill the all the values in the level sum, right? So private void DFS, here tree node, and here int depth. Okay, here you have to check if a node, okay, if it node is equal to null, in that case simply return to the previous level, right? Return if node is equal to null, there's nothing. Otherwise just check if depth value is equal to level sum dot size, right? In this case level sum dot add node dot val, right? Clear this thing, right? Because initially depth 0, right? Initially depth 0, so that simply means first element. Then depth 1, depth 0, you add 1. Then depth 1, first element, right? And size is 1 only, right? 7. Then depth 2, 2 elements are there, and then there is 1 more, right? So we are first, initially very first case, we are checking 1 element every time, right? So that is why I'm applying the logic like this. Okay, else if this is not the case, that simply means that at this particular level we have already some values, right? So here what I will do, level sum dot set the depth, right? At this particular depth, level sum dot get the value at this particular this depth, right? And in this just add the node dot val, right? So this is what we need to do. And I told you that we need to move to the, we need to call this DFS every time, and here we have to move to the node dot left, and then here we have to do depth plus 1. Okay, until we cover all the elements. Same way here, DFS node dot right. Okay, right, and here depth plus 1, right? So once we solve everything, we'll just way back, right? We will just return from here, right? So we are going to fill all the values in the level sum, right? This is done here. Now it is very easy. Now you have to just iterate over all these values and just find the max. Okay, just iterate over the array list, right? So here I will do one thing, int max sum. Initially I will say level sum dot get value at 0 index, right? Done. And here int answer I am going to set it to 1, and then just iterate over all the values starting from 1, right? Int I is equal to 1 because 0 I am already taking above, right? I is less than level sum dot size, and here I plus plus, and here inside this you have to just simply check if level sum dot get the value of I is greater than max sum, right? In this case what you need to do, just update your max sum is equal to level sum dot get the value at I index, and answer is nothing but just update it to I plus 1, right? Why I plus 1? So since array list we used to give indexing like this, right? But this is nothing but level 1, this is nothing but level 2, this is nothing but level 3, so that is why I'm doing like this. Okay, done. Now let's run it. Okay, one more thing, here we have to return this now. So here you have to return answer. Okay, so return answer, that's it. Now let's run it. So see here, only 25 lines of code now, right? Clear? Now let's submit it. So see, our solution is active, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.